Hello everybody, welcome back to math class. Today we have a bit of a shorter video because we have already built the unit circle quite a few times. I'm hoping that you have taken the time to build the unit circle. One thing that you might want to have handy today as we work forward is maybe one that you already have built, maybe your favorite template. As I've mentioned a couple times, if you have access to a printer, there is this template online, or one that looks real similar to it, which has a bunch of nice, beautiful, neat spots for you to fill things in and use colors. These are also, all over that World Wide Web, so you can always just do a quick Google search and have one at your fingertips. I always like to use one that I've already built because I am familiar with how I label things and stuff like that. However, today I'm going to really encourage that you guys step away from using this if you can. Maybe just have one handy. I know that last time we spoke, or last time I spoke at you, we were working through the unit circle and what it means to use the unit circle in order to find various pieces of information, sine, cosine, tangent, and I know that there were some tricky problems involving those reciprocal functions. So I'm just going to use this time to go through a couple trickier ones. Again, showing you how I would use just kind of what I know about the unit circle instead of actually looking at the unit circle itself as we move forward. So let's say, for example, this again is just kind of some review on some of those 13.2 practice problems on the front of that assignment. So let's say that we are going for the cosine of 6 pi. Okay, so for cosine of 6 pi, again, as soon as I see the word cosine, I'm thinking x value or horizontal distance traveled. As soon as I see that 6 pi, I'm thinking to myself, this is going to be more than one rotation around that unit circle. So I've got 2 pi, 4 pi, 6 pi. So I'm going to end up right back here again. And this point right here is going to be 1 unit over 0 units up. So again, cosine of 6 pi is going to be equivalent to 1. Oh my dog is going crazy. Example number 2. Let's say we are looking at cotangent of negative pi over 2. Cotangent of negative pi over 2. So I see cotangent, and what I'm thinking in my head is reciprocal function for tangent. And when I think tangent, I of course think sine over cosine, which means that cotangent is going to be x over y. Okay, I'm just kind of getting the thought there. Now I have to identify where is negative pi over 2. Well, that's half a pi, so I'm going to go backwards. Here's my value. So I'm looking for 0, negative 1. I've already kind of gone through my thinking. So tangent would be negative 1 divided by 0, which would be undefined. Cotangent, however, is going to be 0 divided by negative 1. So cotangent of negative pi over 2 is 0. Okay, I'm going to do one more where we're kind of going forward, where I give you the angle. So how about cosecant of 4 pi over 3? Okay, so cosecant, what should you be kind of thinking in your head? Perfect. Cosecant goes with sine. It's going to be the reciprocal of your sine function. So I'm going to kind of keep this in my head. Sine, of course, is your y value. All right, so now let's find 4 pi over 3. Thirds, okay, those are going to be my taller angle. So 4 pi over 3 is more than a full pi. So remember, 3 pi over 3 is a full pi plus another tall piece. So I'm down here. There's my 4 pi over 3. Okay, so as I identify that tall piece there, I know that this tall piece means I'm going to go left a short distance, down a long distance, but I'm just going to focus on the vertical traveling because I know that I'm dealing with sine cosecant. So it's going to go down the longest distance besides -1. So I know that this y value is going to be -√3/2. And if I were finding the sine at this angle, I would simply use -√3/2, but I would like the cosecant, which means I need to use the reciprocal of that value. So cosecant is actually going to be -2 divided by √3, which of course brings up a whole nother issue because we cannot have a radical in the denominator. So we need to rationalize that denominator by multiplying by good old fancy form of 1, √3/3, which means I end up with, multiply across, -2√3 up top, divided by square root of 3 times square root of 3 is just 3. So my final answer for that one would be as follows. Okay, so now I want to go through, now that we've done a couple of the trickier ones going forward, and again, this was your previous assignment, I would like to try some where we are given the ratio, we're given the value, and we need to work backwards to find that missing angle. Okay, so now we've got a new example, so let's try example 4. What if I were to give you something and it looked like sine of theta is equal to 1/2? And what I'm going to have to do here is I'm going to have to define a set of boundaries, define a domain for where this would exist. I would like this to exist thetas greater than or equal to 0 radians and less than or equal to 2 pi. Because of course, we could just keep going and going and going and going and list out all the possible angles all the way until infinity pi's. So if I'm looking at this one, I need to start thinking backwards once again. So what pops into my head when I think sine of an angle is that this is my y value or my vertical distance traveled. So I know that I'm going to be traveling up as I kind of sketch this out. I'm going to be traveling up. What I know now is my shortest distance. So I know I'm going to be traveling up a short distance here. And also I could travel vertically 1/2 over here. Well, I know right now that up just a teeny tiny distance from my axis, this is going to be my 30s. Okay, but I can't really use 30 because I'm in radians. So my tiniest measurements are going to be pi over 6. And also one small slice of pi back from pi is going to be 5 pi over 6. So within this domain, we are going to be able to say that theta is going to be equal to pi over 6 or 5 pi over 6, because both of those exist. Okay, I'm going to try another example here. I've got about 2 or 3 more, and that's it for today. What am I on? Number 5? Okay, example number 5. Okay, again, I'm trying to get you all away from using that beautiful unit circle that you've made and really try to conceptualize what you're looking at here. So the next one, I'm going to try to ask you to find the cosine of theta. I'm going to find that theta when your cosine value is -√2/2. And this time, I'm going to limit your domain to be theta greater than or equal to 0 and less than or equal to pi. Okay, so what pops into your head when you see cosine, I'm hoping is your x value or your horizontal distance. When I see a negative, I know I'm going to have to travel left. And when I see √2/2's, I'm automatically thinking 45s, I'm thinking pi over 4s, because anytime I see that root 2 over 2, I know that I'm thinking about that angle in my unit circle. All right, so I'm thinking I'm going to be going left. So my angle is going to exist in this piece of the unit circle. When I go left root 2 over 2, I can either travel to this pi over 4 angle. I can also travel to this pi over 4 angle. So when I think about the unit circle, this one is going to be 3 pi over 4, would give you a cosine value of left root 2 over 2. And then also this one would be 5 pi over 4, which also gives you a cosine value of left root 2 over 2. However, if you're taking that SAT, don't choose the one that has both of these, because our domain is restricted. We can only travel on the unit circle from 0 to pi, which means that the only value that lies within this domain is going to be theta equal to 3 pi over 4. That's it. 5 pi over 4 is outside of our restricted domain. So be careful about that limited domain. Make sure that you see where you're going to be able to live. All right, so let's try example 6. And then maybe we'll do like a really tough one. Let's try example 6. Let's try tangent of theta is -1. Okay, tangent gets a little tricky, because tangent, of course, what pops in your head is not just one dimension, but 2. So with enough experience with tangent so far, tangent's going to be y divided by x. Well, what is the only thing you could divide by that's going to give you a value of 1? Well, the only thing that's going to be able to get is something equal to something else. These have to be equivalent numbers. Don't mind that sound. It's just my dog going insane. And let's restrict the domain to be any theta greater than or equal to 0 and less than or equal to, let's go all the way to 2 pi this time, so you're dealing with the whole unit circle. Okay, so I'm going to be looking at those root 2 over 2 divided by root 2 over 2, which means I'm limited to my 45s or my pi over 4s as we go. All right, so here's my unit circle. I've got a 45 degree here, but remember I need to end up with a -1, and this one's going to be positive divided by positive. Okay, well, quadrant 3 is going to be a negative divided by a negative, which is also going to end up at a positive. So that won't work, which means the values that I'm looking for are going to lie here or here, because I will end up with negative root 2 over 2 divided by positive root 2 over 2. So this value right here, theta equal to 3 pi over 4, would be one of your possibilities for theta. And also this one, which would be a negative divided by a positive. And that one is going to be your 7 pi over 4. So within the domain, there are 2 places where your tangent is going to be -1. All right, we've got one more to try. Example 7. What if I asked you for the secant of theta equals -2? Okay, well, when I see this, I immediately get a little bit uncomfortable, because -2 is not one of my ratio values on my unit circle. So I automatically think that I should probably skip this one. Just kidding. But you know that's what you think. But if you think a little more deeply about secant, who does secant relate with? Who is your reciprocal function for secant? Well, the reciprocal function for secant is, of course, cosine. So when I think about cosine, I'm thinking about those x values, that horizontal distance traveled. And if I think reciprocal, if I make -2 reciprocal, this is going to be -1/2. And I absolutely know that -1/2 is a very valid ratio on my unit circle, which means I'm going to now be traveling left 1/2. So if I'm going left 1/2, I feel like we did this one already. No, maybe not. All right, if I'm going left just a little bit, that means that I'm living at my tall angles here. So secant of theta being -2 is the same exact thing as cosine of theta being -1/2, which means that I'm going to be looking at these two angles, which are 2 pi over 3, and then one more, so 4 pi over 3. So theta is 2 pi over 3 or 4 pi over 3. Okay, so just a quick lesson today, about 15 minutes or so, about working through that unit circle. We did a couple of examples moving forward where you're looking for the value at a certain angle. And then a couple of examples working backwards where you've been given your value and you're looking backwards at that angle depending on your domain restriction. So your practice problems tonight are to be the back of 13.2. Again, this was lesson 13.2 part 2. So you're going to be looking at the back of that activity where you're going to be working backwards. The extent, and also, if we were in regular school, you guys would be given these unit circle quizzes where you have 5 questions and you are simply trying to work that unit circle. Sine, cosine, tangent, give me what the value is over and over and over again. We are asking that you only complete one of these quizzes today for your homework. Just take a look. As you'll notice, if you look at the attachment on Planbook, we not only have one quiz, we actually have 4 little quizzes. So if you would like to get more practice, it is there for you. I attached all of these onto Planbook. Again, they're quizzes, not quizzes. Just kidding, not this year. And all of the answers are going to be on the back. And as you can see, I gave you little pictures to help you. So I know you have a couple days left. You should be going into a weekend here. This is just a chance to get to know that unit circle better and better and better. The better you can do with this unit circle, the more equipped you will be to move into trig functions, which is where we will pick up next week, or week 3 of remote learning. So thank you for playing. That's it. We will have Zoom sessions tomorrow to answer your questions and work through some of these. Have a great day.